Okay. It says number 4. This is A-4. We'll do another 4. It says a flea gains one time. This is a good practice for scientific notation. It says a flea gains 1 times 10 to the negative 7. So the change in potential energy for this flea is 1.0 times 10 to the negative 7 joules. Okay? By jumping a height of 0.03 meters. So the change in height is 0.03 meters. It's 3 centimeters. That's it's like this, right? It's a flea doing it. From a dog's back. A flea gains 1 times 10 to the negative 7 joules of potential energy jumping up to a height of 0.03 meters from a dog's back. What is the mass of the flea? So here's the data. You need to do the mass. Okay? So we know that it's going to be delta PE equals mgh. So this is going to be 1 times 10 to the negative 7, correct? We'll leave off the unit labels as long as they're all correct. Meters, joules, you're good. You'll get kilograms if these are the correct unit labels. You'll get kilograms. Understood? You're guaranteed. M is what we're looking for. This is 10, and this is 0.03. So what is 1 times 10 to the negative 7 divided by 10 divided by 0.03? What do you get? Yes. 3.3 times 10 to the negative 7 kilograms. If you ever wondered the mass of a flea, there it is. Okay? Very small flea. You can see a flea. Not easily, but yeah, you can see fleas. I've had many dogs in my life growing up, and for my children when they were younger. Yeah, fleas are horrible creatures. Make you itch. Okay, is that good? Shall we do the next one? We'll do A5. Any questions on this? You okay? Yeah. Okay, it says, at target practice, Diana holds her bow and pulls the arrow back a distance of 0.3 meters by exerting an average force of 40 newtons. What is the potential energy stored in the bow at the moment before the arrow is released? Do you know what they're talking about? You have a bow, right? Let's say it's recurved, right? It's a terrible bow, and you're pulling the string back. So you have the bow and you're pulling the string back. Yes? You understand? Yes? And it's a terrible drawing, I apologize. Terrible at art. And so, it says, holds her bow and pulls the arrow back a distance of 0.3 meters. And she used a force of 40 newtons. Okay? What potential energy is stored in the bow? Change in potential energy equals the work equals FD. What's FD going to be? What is 0.3 times 40. You should be able to do that in your head. 0.3 times 40 is 12. So it's going to equal, so the change in potential energy, sorry, I put F. So this change in potential energy is going to be 12 joules. Easy peasy. That was an easy one. Yes. Next one is also pretty easy. Okay. You okay with that? Any questions? Yes? No? Okay. 5. That was 5, right? That was 5. So 6. The coyote, whose mass is 20 kilograms, 20 kilograms, is chasing the roadrunner when the coyote accidentally runs off the edge of a cliff and plummets to the ground 30 meters below. What force does the ground exert on the coyote as he makes a coyote-shaped dent 0.42 meters deep in the ground? Cartoons often contain some unusual laws of physics. Okay, so the depth, we'll say D for depth, is 0.42 meters. Do you understand what it's doing? So it's jumping off the cliff and hitting the ground and making an indentation. You understand? It's making an indentation. So here's the cliff, here's the ground, and it makes this coyote indentation into the ground. Correct? And this is going to be 30 meters, and this is going to be 0.42 meters. Okay? And it wants to know what force does the ground exert on the coyote as he makes the coyote-shaped dent. Okay? So what do we got? Anybody? Anybody? So when it hits the ground, what's going to be the change in potential energy when the coyote hits the ground? Or the roadrunner or the coyote? The coyote. What's going to be? Mata, you look like you're in agony. I feel like I'm torturing students. You okay? Just tired. Okay. So what's going to be, what is it going to bring into it? What work is it going to bring into it? Because remember, the work here, that work, right? That's work, right? That's got to equal this work. Right? So what work, what change in potential energy is it bringing into it? Right? Because didn't it have a certain amount of energy when it hit this? Didn't it have a certain amount of energy? And that energy was used up, correct? Yes? Okay. So let's get the energy first it's bringing in. So the change in potential energy, we'll call it the work, equals 20 times 10 times 30. Can you see that? Is that written too small? Is that okay? Yeah, you can see that. So this amount of energy that it's digging this hole with, literally digging the hole with, is going to be 20 kilograms times 10 meters per second squared times 30 meters, right? So what is that? What is 20 times 10 times 30? What is it? 6,000. Okay? So it's doing it, it's digging this hole with 6,000 joules, correct? Yes? What distance does it dig to? It's going to start at the surface of the canyon, right? It's going to bring 6,000 joules to the process. How far down is it going to go? 0.42 meters, correct? So it's going to be 0.42 meters, and then there's a certain force, correct? Can you see that? Do I have to change let me change the card a little bit. Okay, so you're going to bring 6,000 joules into it. You're going to go down a depth, a distance of 0.42. What force? So isn't it 6,000 divided by 0.42? And Isis has the answer. It's going to be, all right, 14, let's round it, 14,286. Is that right, what you got? 14,286. So then the force equals 14,286 newtons. As long as this is meters, this is joules, you're okay. Because joules is really Newton meters, right? Yeah, okay. So that's what you have. Clear? Does that make sense? Easy? Little twist, yes? In other words, the coyote's jumping off the hill, gaining a kinetic energy of 6,000 newtons, right? So now he has right here at the top of that height, he has a potential energy of 6,000, correct? Right? So that's the kinetic energy. So now it's stored as potential energy just before it hits that hill. Yes? And he's going to spend 6,000 joules to go 0.42 meters. And he's going to use a force of 14,286 newtons. And the coyote will live. You will not, but the coyote will, because that's a cartoon. Okay. This is not real. I hope you know that. Okay. Very good. Okay? Easy? Most excellent, guys. So now, what number are we on now? 7? Yes? 8? What number did we just do? We just did number 6. Now we're on 7. Okay? All right, let's do 7. It says, 7 is in 2 parts, a 0.08 kilogram robin. Everybody know what a robin is? Everybody know what a robin is? A robin is a bird. Very common bird in North America. I don't see them around here, but who knows? Okay? All right. It's perched on a power line 6 meters above the ground. So the height is 6 meters. It swoops down to snatch a worm from the ground and then returns to an 8-meter high branch with its catch. So then, this is height 1, height 2 is 8 meters. Okay? All right. A. By how much did the bird's potential energy increase in its trip from the power line to the branch? How much did it increase from the power line to the branch? So the power line to the branch. How much, so the change in potential energy will equal mgh, and that'll be kilograms, meters, we're okay. Times 10 times 2. And what does that equal? Correct? What do we got? Anybody? What do we got? What do we got? What do we got? What is it? What?
1.6.
1.6. What does that mean? 1.6. Joules, thank you. 1.6 joules. No unilabels, no credit. I know, aren't I mean? Good. Okay. It's important. This isn't math class. It's science. We have to label the identity of measurements. Okay, so what else? It says, how would your answer have changed if the bird had flown around a bit before landing on the branch? Would it be the same, different, what? It would be the same. It would be the same. The change in energy is independent of the path. Clear? The change in energy is independent of the path. All right, one more, and then we'll stop this tape. Now we're going to do 8. We'll do 8. Cinnamon. What time is it? Oh, we got plenty of time. Cinnamon, whose mass is 5.45. Says cinnamon, whose mass is 5.45 kilograms, was adopted from a cat shelter. That's a big cat, 5.45 kilograms, isn't it? All right, that's okay. I think cinnamon needs to go on maybe a diet. Okay, what do I know? And now enjoys napping on top of the refrigerator. Cinnamon rolls over and falls off the refrigerator, landing feet first with a kinetic energy of 85.5. The kinetic energy is 85.5 joules. Correct? As she hits. How tall is the refrigerator? Cinnamon, whose mass is 5.45 kilograms, was adopted from a cat shelter, now enjoys napping on top of the refrigerator. Cinnamon rolls over and falls off the refrigerator, landing feet first, with a kinetic energy of 85.5 joules as she hits. How tall is the refrigerator? Well, the change in potential energy equals the change in kinetic energy equals mgh, correct? So this is going to be 85.5 joules equals m 5.45 kilograms. I'm putting in the unit labels, I really don't need to. And then times 10 and time h. All right, so what is 85.5 joules divided by 54.5? So we got like, what do we got? What does that say? Okay, 1.6, we're rounding. Is that okay with everybody? 1.6, and it's meters. How do I know it's meters? Because I'm calculating a height. That's 10 meters per second squared. Those are correct unit labels. Masses, kilograms, and the power, not the power, the work, potential kinetic energy is joules. Okay? Right? That was number 8. All right? All right, very good.